Hello everyone, Assalamualaikum. Today my group and I are going to present our assignment, which is Project Audio Amplifier. Before we begin, let me introduce our team members. I'm Nur Izzati binti Muhammad Zani. Next is Zaito Khadijah, and lastly is Aisyah binti Ruslan. Next, our content is abstract, introduction, project methodology, multi-sim circuit, calculation, result, and conclusion. For abstract, this project aims to design and develop a prototype audio amplifier that can drive a speaker with a power output of more than 5 watts over a reasonable audio frequency range of 300 Hz to 3 kHz. The prototype employs bipolar junction transistor BJT and or field effect transistor FET as the core component. The design process includes selecting appropriate component, performing calculation for amplifier gain, output, voltage and current, and validating the circuit through simulation using multisim. The final design will be demonstrated through a video presentation and document in a technical report following IEEE standard. For introduction, an amplifier is an electronic device that makes a weak signal stronger in voltage, current, or power. It is important that while the signal gets stronger, its shape stays the same. The common emitter amplifier is a simple device that uses a special type of transistor to amplify voltage. The input comes from one part called the base, and the output comes from another part called the collector, while a third part called the emitter connects both. When a signal is put into the emitter base junction, it allows more electrons to flow from the emitter to the collector, which is increase the collector current. This rise in collector current causes a bigger voltage drop across a resistor connected to the collector. The current gain of the amplifier is the change in collector current divided by the change in base current. The voltage gain is found by multiplying the current gain with the ratio of the output resistance to input resistance.
For next part is project methodology. First step is specification analysis. Determine input and output device requirement such as microphone, amplifier, and speaker. Analyze datasheet of selected components to ensure compatibility with design specification. Step 2. Circuit design. Choose suitable amplifier configuration such as common emitter or common source. Perform theoretical calculation for DC analysis and AC analysis to determine amplifier gain, output voltage, and current. Step 3. Simulation. Use simulation to design and simulate the amplifier circuit. Validate performance metrics such as gain, frequency response, and power output. For step 4, analysis and comparison, compare the simulation result with both the DC and AC theoretical calculation. Analysis of the simulation result is validated to the theoretical prediction. Discuss the simulation approach in achieve the desired amplifier characteristic. And last step for project methodology is documentation and presentation. Prepare a technical report in IEE format, including calculation, simulation, and experimental result. Record and upload a demonstration video of the prototype's performance.
Assalamualaikum. My name is Zaitul Khadijah and I'm going to present about our circuit. So this is a BJT common emitter amplifier single stage, and as we can see the VCC is 12 volt, while the amplitude from the function generator we inject the 150 millivolt peak to peak, while the frequency is 1 kilohertz. The value for R1 is 22K. The R2 is 6.8 kilo ohm, RC1 is 1 kilo ohm, RE is 560 ohm, and lastly the RL is 10 kilo ohm. So we use only one transistor, which is 2N3904 transistor. Next, I will explain on how to do the calculation. First, we need to find the RTH. We need to use the equivalent of R1 with R2. So we get 5.19 kilo ohm. Next, the value for VTH is 2.83 volt. And the formula to find the IE is VTH minus VPE divided by RE plus RTH divided by beta DC. So the value of IE is 3.58 milliampere. The value of IC will be equal all around IE, which is 3.58 milliampere. VE will be equal IE times with RE, so we get 2 volt. Next is VB equal to VE plus VBE, which is we get 2.7 volt. VC equal to VCC minus with IC times with RC, we get 8.42 volt. And lastly, to find the value of VCE equal to VC minus VE equal to 6.42 volt. Next, to find the value of IP, we need to apply the KVL, which is Kirchhoff voltage law, and then we can find the IP. In this case, our IP is 22.28 microampere. Next, to find voltage gain, we use the formula V out divided by V in, and then we get negative 1.603, which is the negative sign indicate the phase reversal. Next is how to calculate the impedance. We use the beta RE plus V. 1 plus beta times with RE, we get 85.65 kilo ohm. The Z in equal to RTH equivalent with ZB equal to 4.89 kilo ohm. And lastly, Z out is equal to 909.09 ohm. To find AI, we use the formula AV times with Z in divided by Z out. So we get 8.62. Next is AP equal to AV times with AI, we get 13.82. And lastly, we also calculate the voltage gain in decibel. For AV, we get 4.10 decibel, while the current gain is 18.71 decibel, and lastly the power gain in decibel is 11.41 decibel. So this is the simulation result from the multisim. We use the multimeter to find the value of voltage, which is VE, VB, and also VC. Next, we find the value of VCE and also VPE. From the simulation result, we know that the value is not far enough from our calculation. And lastly, we use the oscilloscope and inject it at the V in and also V out, so we can display the amplitude. So this is the simulation result from the multisim. We use the multimeter to find the value of voltage, which is VE, VB, and also VC. Next, we find the value of VCE and also VPE from the simulation.
In conclusion, amplifier help make a small signal stronger by increasing its voltage, current, or power. A small signal amplifier only uses part of its capacity when there is a signal. To find out how much the voltage increase, you divide the input voltage by the output voltage. The common base small signal amplifier is the best for increasing voltage because it gives the highest voltage gain. The common emitter, small signal amplifier, is next and it flips the signal by 180 degrees from input to output. The common collector, small signal amplifier, has the lowest voltage gain and keeps the input and output signal in phase. In a small signal amplifier, the emitter can act as both an input and an output. While the base and collector have specific role, the transistor works as an amplifier when the base collector and base emitter connection are in the right setting. In a common base collector small signal amplifier, the emitter is the output and the base is the input. The collector is shared between the base and emitter, hence it acts as ground.
So that's all from us. Thank you.